Stan Gibilisco here. I would like to introduce a website entitled Nerd Cave Hypotheses. In order to get to it, just go to my website, sciencewriter.net, and then type a /NCH, Nerd Cave Hypotheses. I will include a link to that site in the description of this video. But in particular, I want to thank viewers for subscribing and contributing to all of these Nerd Cave vlog discussions, and in particular, the one about the proof that -1 equals 1. It seems like there's a couple of problems or a couple of glitches along the lines of that proof. First of all, when we talk about the square root of -1, that can be either I, the unit imaginary number, or -I, the negative of I. And it turns out that I and -I are not equal to each other, just like 1 and -1 are not equal to each other. In the proof, I neglected that dichotomy, and therefore it gave rise to some confusion, and that is one of the answers that I got, one of the comments that I got. And I think it's a valid point. Now, what I'd like to get at here, there's also the other issue that my nephew brought up by email. He didn't actually leave a comment. I'm not sure why he has not yet gotten a YouTube account and subscribed here. It would be great for him, but the square root of 1 can equal either 1 or -1, because 1 squared equals 1 and -1 squared also equals 1. So I guess I should get rid of the radical sign now there, shouldn't I? So that is basically what we're dealing with here, is a quadratic equation of some sort or another in an extreme simplistic form. X squared equals 1. X squared equals -1. Now, when we have a quadratic this simple, these are very simple quadratics, but when we have something that simple, I guess if you want to put these equations in formal quadratic form, x squared -1 equals 0, x squared plus 1 equals 0. The solution set to this particular equation, the top one here, turns out to be 1 -1. That is how we use set notation to describe things. We list the elements and then we enclose it in curly brackets to indicate that it's a set. The solution set to this equation, on the other hand, is I minus I. Or if you're an engineer, you might prefer to use J, the J operator, the unit imaginary number. By the way, I have a complex number primer on my main YouTube channel, Stan Gibilisco. Just go to the playlist Complex Number Primer. I believe I recorded all those on an iPad sitting in front of a whiteboard or something like that, long before I had such highfalutin software as what I'm using for this. But we get into a kind of a conundrum here, because when we talk about a solution set, are we talking about 1 or -1? Are we talking about I or -I? Is it an either-or situation? Or is there some way that we can consider these solutions to be two-valued numbers? Can we do that? Can we get away with that? And I got very interested in this issue when I was back in my college days, when I was trying to evaluate the quantity 1 divided by 0 and trying to define division by 0. A lot of people have tried to do it. It leads to a lot of weird stuff. That's why I suggest you go to the Nerd Cave Hypotheses, because there's a lot of that weird stuff in there. That is, I actually scanned these handwritten documents that I made more than 40 years ago. Maybe some of them are typewritten, but I actually scanned them and made PDFs out of them, and you can view them directly on an iPad. Otherwise, on some computers, you may have to download them, but feel free to download them and distribute them to your heart's content and your brain's demise. In any case, when we're talking about the solution to this equation, or the solution to this equation, the best we can do so far is call it a set. There's a set of solutions. But suppose that instead we decide to say that the solution to this equation up here, the top one, is a two-valued number, 1 and minus 1. It has two values at the same time, as it were, simultaneously. It's not an either-or situation, it's an and situation. Similarly, down here, we have a two-valued imaginary number, I and minus I. And in order to denote those types of situations where we have two-valued or three-valued or even infinitely many-valued numbers, I would enclose the entire list in square brackets rather than in curly brackets as you would do to indicate a set. So when you go to the Nerd Cave Hypotheses and you look at the numerical entities paper that I wrote, when you do that, you'll find a notation like this, and it goes a lot deeper, though. There's a lot of cool stuff that happens with numerical entities like this. Numerical entities is what I called them, and to this day, I think that sounds sort of cool, don't you? Rather than multivalued numbers or fuzzy numbers or something like that. Numerical entities. Now, I thought I couldn't possibly be the first person who thought this stuff up. Even back in college, I was thinking, there's no way I can be the first person who thought this stuff up. But I never really found any papers or books or anything that dealt with the concept. But just maybe 3 or 4 years ago, probably 40 years after I first penned my first edition of Numerical Entities, or the Theory of Numerical Entities, sitting in the study carrels at the Chi Psi Lodge fraternity house at the University of Minnesota, where it was either 50 degrees or 100 degrees, but never anything in between. Great for thinking. Great brain food temperatures. Numerical entities. I thought there's got to be somebody else who thought this up. And I also thought I was doing this as a love of mathematics, maths, as an art form. Much the same way as someone I greatly admire to this day. I would have aspired to be like him, but I just didn't have the academic gall to do it. G.H. Hardy, who lived about 100 years ago, a pure mathematician out of England. And I also would aspire to be like my college professor the very first semester I ever had. His name was John Dyer Bennett at Carleton College Carleton College in Minnesota. And people said, "Oh, don't take a course from this guy. Don't take a course from him. He'll give you a B when everybody else gives you an A and all this." Well, he gave me an A, and he would have been a great mentor for me to aspire to someone like G.H. Hardy, a rigorous, ironclad, pure mathematician who took mathematics as an art form and disdained applications, looked at applications as weak mind fodder. The artists, the mathematicians dream up the theories, and then the weak minds do things with it, like find ways to kill people. And in fact, I thought someone will take the theory of numerical entities or something like it. Someone will take this theory, this pure mathematics, and find an application for it which contributes to the murder of people. And in fact, I found that in the 1930s, someone had dreamed up a theory very similar to this. And today, they are using that theory to more precisely aim missiles at their targets, presumably living beings. With that, once again, I invite you to go to my website, sciencewriter.net. Then type a slash, and then type NCH, November, Charlie, Hotel, for those of you who are into phonetics, and look at numerical entities and all the other stuff I've done. And if you intend to use it to find a way to kill people, don't tell me. I don't want to know. Stan Gibilisco, signing off for now from the Black Hills, soon to be white once again, with possibly as much as 2 feet of snow. So long.